Hello, everybody. This is Alex Voss from TV eCourse, and I want to talk to you about how television works. Now, we're going to watch a public domain film, which is very old and talks about television as it was made way back when. However, the principles still apply. I'm a broadcast engineer. I'm a member of the Society of Broadcast Engineers, and for years we were working with a system called 480i, which is 480 lines interlaced, and we had actually 525 lines with 480 visible with two fields, with 262 and one half lines in one field and 262 and one half lines in another field. And that made up our broadcast, what we called NTSC, standard definition television system. Well, of course, now here comes high def, and we have many forms of high def. We have the 1080i, which stands for 1080 interlaced, and then we have 720p, which stands for 720 lines vertical progressive. And when I say 1080i, 720p, 480i, I'm talking about vertical lines, and then you have the amount of signal going across the horizontal line, the number of pixels information on the horizontal line, and that also gives you, your quality, your resolution, your high definition resolution. However, scanning principles, frame rate, signals, they're all still the same theory. So if you understood the theory about how 480i works, then you understand the theory behind 1080i, 720p, or basically any television system on the planet that depends on scanning from the upper left-hand corner and going to the right, and then repeating lines all the way to the bottom and scanning back to the top. Sometimes in progressive, you just do one scan. Sometimes in interlaced, what you do is you start in the upper left-hand corner, go to the right, and scan to the bottom middle, and you scan from the bottom middle back up to the middle top, and you start there, and you do your two fields. And of course, two fields make a frame. The frame rate in television is 30 hertz, 29.958 if you want to be really technical, or 60 fields. That's to get around flickers, so you don't see a flicker in the picture. Compared to film, which is 24. And so there's a lot of basis in the theory of how television works. And so I've got this wonderful archive film made by the U.S. Air Force on how television works, and even though it's done way back when, the theory still applies, and the way they dissect an image still applies, and so we can learn a lot from this and get a better understanding of how a TV works. I appreciate you, and let's go to the film now.
Aside from broadcasting sound, television, simply consists of taking pictures and sending those pictures out over the air at the same time. As you might expect, a camera is used for the photography, just as in any other kind of picture taking. Only there's no film in the television camera. Developing film and printing pictures takes too long. Besides, you can't broadcast paper pictures. You can, however, broadcast electrical pictures, and those are the kind that the television camera takes. Behind the lens of the camera is a special plate in a glass tube, one of the great developments in the promising science of electronics. This plate is a fascinating device. It's completely covered with millions of tiny electric eyes, which of course are sensitive to light. When light strikes them, they become charged with electricity, and the amount of electricity they develop depends upon the amount of light striking them. The more light, the greater the electric charge. Now, any scene is made up of various points of light and shadow. Some sections are light, some dark, some are in between. Here, for example, the jackets are lighter than the trousers, so naturally they create greater charges of electricity on the plate than the trousers do. All the shading and details of a scene are reproduced the same way. The electric eyes see the various differences in light levels and develop electric charges to match them. Combined, these charges form electric pictures of the scene, which are sent out immediately. Each picture does not go out all at once, however, as a snapshot might through the mail. Like a telegraph message, it's sent bit by bit, arriving at the receivers piecemeal. The charge in each electric eye becomes an electric impulse and dashes merrily away by itself, the other impulses following in single file, one after the other. As they reach a receiver, they strike the screen in order and are transformed back into points of light and shadow. Of course, the process is much faster than you see it here. It has to be to keep you from noticing the mechanics of it, to keep up with any action in the scene, and to give the illusion of motion. We've just slowed it down so you could see how it's done. Now we'll speed it up. 30 complete pictures go out every second in the form of single electric impulses. And every second, 4 million impulses reach the receiver screen, one after the other.
Gosh.
It sounds unreasonable, I know, but it's quite true.